We will be presenting a presentation on Point Pleasant Park and the forest's ecological changes after devastating Hurricane Juan. It will be presented by Tristan, Solomon, and Ian. Point Pleasant Park is located in Halifax, Nova Scotia. Amtukati means spirit place and is very important to the Mi'kmaq community because they believed it was the place where the Great Spirit Fire sat, whose sparks gave birth to the 7 original families of their people. Forests are also important to create biodiversity among cities. This park was devastated by Hurricane Juan in 2003 with 70% of the tree canopy lost, and it caused the park to close for 8 months to allow cleanup. Since the hurricane, researchers have surveyed 6 sites in the park where the hurricane caused the greatest damage to evaluate the effects of the hurricane on the trees and how/if they're able to regrow, along with studying the ecological succession in the park with relation to management goals. It is home to a mixture of coniferous and deciduous trees, but it is dominated by red spruce and white pine. Past hurricane studies on the forest have shown that structurally the forest after the hurricane is patchy and variable. However, the species composition changes were limited. Another study showed that even though the hurricane had a very strong influence on the community, it did not promote non-native species to move in. Important acronyms for this study are DBH, diameter of breast height, and PPP, Point Pleasant Park. In our study, we evaluated using the species richness, Shannon diversity, evenness, and looked at the dominant species density over time. Our hypothesis is as stated in the order of each scientific question. The species in Point Pleasant Park will increase over time after the hurricane and will recover, showing signs of ecological succession. The density of red spruce and red maple has changed over time, with red maple becoming more dominant over time due to its ability to tolerate shade. As the forest continues to recover, we expect tree density to gradually increase, while species diversity will level off at a moderate rate. The distribution of species will become more even, and over time, shade-tolerant species that thrive in the forest will start to dominate, signaling the transition towards a stable climax community. Our null hypothesis is as stated. There will be no change in the species richness and diversity in Point Pleasant Park, and there will be no ecological succession. There will be no significant change in the density of red spruce and/or red maple over time. There will be no significant progress toward becoming a climax community, and there will be little to no change in tree density, species diversity, or how species are distributed.
Our study took place in Point Pleasant Park, Halifax, where we monitored forest recovery after Hurricane Juan in 2003. To track change, 6 20 by 20 meter plots were set up in 2004 for long-term data collection. For tree data collection, we measured living trees with diameters at breast height of at least 2.5 centimeter, taking at 4.5 feet above ground. We recorded tree species and density per 400 meters square. In data analysis, we examined species richness, Shannon diversity index, and Peleus evenness. Also, we did dominant species density. We used linear regression analysis to track trends in species diversity and density over time, helping us understand forest recovery and ecological succession.
The overall forest community had an increase in Shannon diversity over time, meaning that there was an increase in the diversity of species in the forest community at Point Pleasant Park. After 2010, there was a significant increase in the number of species present in Point Pleasant Park, with most values being 1.5 and above, which indicates that there are more species present. In 2020, there was a slight decrease in the Shannon diversity index, with numbers being around 0.5 to 1.5. But the community stabilized quickly back to values of 1 to 2 by the next year. This means that the community is showing signs of recovery and species were able to regrow and rehabilitate after the devastating hurricane. A null was rejected, determined by the linear regression analysis, and the alternative hypothesis was supported that was as stated. The species in Point Pleasant Park will increase over time after the hurricane and will recover, showing signs of ecological succession. In the future, the data trends show that there will be an increase in the diversity of species at Point Pleasant Park, and shows hope that in the future the community will be able to reach a balance between diversity and stability. And in future hurricane events, the community will be better able to survive the high winds, rain, and effects of the event.
Before Hurricane Juan in 2003, red spruce was the dominant tree species in Point Pleasant Park. However, after the hurricane cleared much of the canopy, fast-growing species like red maple quickly established dominancy. Over the study period, red maple increased at a much higher rate than red spruce, the slope indicating that red maple established nearly 7.5 times faster than red spruce. Given this result, we reject the null hypothesis, which stated that there would be no significant change in the density of red spruce and red maple over time. Now, in 2024, we see a sign of secondary succession taking place. Red spruce is gradually increasing, although its growth has been slower than red maple. This is expected, as shade-tolerant late successional species take longer time to establish dominancy. As the forest matures, we predict that red spruce will become more dominant while red maple may decline. This follows the expected forest recovery pattern, where early successional species are replaced by longer shade-tolerant species over time, as they are better competitors.
The species richness has had a fairly linear increase throughout time in practically all plots in the Point Pleasant Park data collection. All of the plots have had an increase in richness significantly from 2004 to 2024. All the plots have not been completely dominated by one species, although some plots are less rich than others. All of the data describes how that over time, in all plots, more and more species were being introduced through natural processes. Some of the less rich plots could be due to the harsh competition factors or growth factors, making it more difficult for some species that would thrive in other plots to not be successful in some. As the forest approaches the climax community metric of species richness, I believe that it will be initially increase, and once it reaches the climax, it will level off and possibly have a slight decline. Originally, many pioneer species will be established, then the less adapted and slower dispersing species will arrive. Depending on the adaptability and competition capabilities of the species in the plot after the climax, species may begin to be snuffed out or forced to disperse elsewhere. Forest in Point Pleasant Park is in the mid-succession stage. This is shown by the increase in species diversity, the reintroduction of red spruce through secondary succession, and the overall species richness trends. Point Pleasant Park faces challenges such as human disturbance and the introduction of invasive species. Integrating Mi'kmaq traditional knowledge, particularly the two-eyed seeing method, can potentially improve the knowledge in recovery strategies. Strategies may be observing natural cycles to identify critical species and managing them to encourage late succession in these species like red spruce. This process promotes a resilient and sustainable ecosystem that fit the natural progression of the Point Pleasant Park forest.
We would like to thank our lab instructor Allison and our DM Abigail, along with the Mi'kmaq community, for allowing us to research on land sacred to them. These are the references used for our presentation, and we thank you for listening.
There's an array of issues that could stand in the way of the quality of data being collected in the future. Climate change being the major concern, bringing weather and climate conditions that are straying further away from either sides of the optima for most of the species present within the park. Urbanization of Halifax may play a role in the diminishing of the quality of the park's ecosystem, whether it be the destruction of the ecosystem or pollution from constructions and operations. If the correct care of the park isn't carried out, then it may be difficult to receive any sort of viable data that would be useful to understanding the trends of any other Acadian forest.
The effects of Hurricane Juan on the rest of the forest ecosystem was habitat loss for species including animals along with the displacement of those animals, along with the risk of invasive species overtaking the native species due to them being vulnerable. There was also an increase in sunlight due to the destruction of the trees that allowed plants on the forest floor to thrive more. Since a hurricane brought high winds and rain, it led to soil erosion, but it also led to nutrient cycling due to more trees decomposing. Small mammals and birds, along with decomposers, were able to return the quickest and thrive in the forest post-hurricane due to little to no predators, lots of scavenging opportunities, and decomposing material for food. Faster growing plants will take over the forest first due to the fact that they can grow quick, but due to competition, the slower growing plants and trees will replace them. Once the forest is more established, the larger animals will return. Due to the hurricane, there was forest changes that occurred upon the forest ecosystem, including new species and new habitats, creating a new ecosystem dynamic compared to the forest before the hurricane.
As our results show, Point Pleasant Park is undergoing natural recovery following hurricane disturbance, with an increase in species richness and diversity over time. To ensure a balanced and resilient forest ecosystem, it's important to encourage natural succession while maintaining a species balance. That means supporting gradual return of late successional species like red spruce, while spruce will help restore the forest's long-term stability while preventing the over-dominancy of fast-growing pioneers like red maple to maintain biodiversity and ecological resilience. Another key strategy would be enhancing storm resilience through structural diversity. Forests that include multi-aged and multi-layered trees act as natural windbreaks, reducing damage from future storms. Finally, it is also important to involve community in long-term forest monitoring and education. By integrating Western science and indigenous knowledge, we can develop a public program that educates people on hurricane impacts and forest recovery. Encouraging community-led monitoring initiatives will help track succession trends, engage the locals, and create more adaptive management strategies for future disturbance.